Yeah, let's get started. Okay, hi, good afternoon, everyone. So as I did mention, we need to catch up on a couple of things because you guys are a bit behind the other classes. All right, so the notes where I filled up last time, I did until here. I did tell you that before you do any work, you're supposed to have continued further on your own, and you're expected to independently read the textbook on the extra bits on mass spectrometer on your own before we actually cover through it. As I did go through this already, I'll just quickly go through the idea because it seems like a couple of people couldn't get the idea last time. So here you have three different isotopes. These are isotopes because of the definition of isotopes. These are different atoms, but they are for the same element, since you could see that their symbol are the same. So that means they have the same number of protons, but because they are atoms, that means they also have the same number of electrons since they have the same number of protons. Then what is different is this mass number, and the mass number, basically the nucleon number. And then when you when you know that they have the same number of protons, then you know that you could compare 16 oxygen. Sorry, you call them oxygen 16, oxygen 17, oxygen 18. What you could do in this kind of thing is to work out the protons and the neutrons as well as the electrons. But as I said, the number of protons, they're all going to be 8, 8, and 8. You know from the periodic table next to you, oxygen is element number 8. In terms of the electron, it'll also be 8, 8, and 8 because these are all atoms, but they are for the same element. For the neutron number, is this number on top minus the proton number. 16 minus 8 is 8, 17 minus 8 is 9, 18 minus 8 is 10. So same number of protons, same number of electrons, different number of neutrons. This thing is about mass spectrometer. Your mass spectrometer is a specialized kind of apparatus. You don't have it in school. It's very expensive. What it detects is it detects masses. Electrons are very, very light. It's about 2,000 times lighter. When you lose one electron, the mass is almost not visible at all because you are just losing one electron. That's why you have a +1 for the molecule. But the majority of the masses come from the nucleus. Inside the nucleus, you have the nucleons because of the definition of nucleons, NuCleon. The nucleon number, which is the mass number, is going to be the sum of the possible isotopes, which in this case are 16, 17, and 18. You get two atoms, 16, 16, 16, 17, 16, 18. They give you these particular masses from the two atoms. And I showed you last time, you could have 17, 16, 17, 17, 17, 18. But this thing will overlap with the 33. So these are not a new mass. This mass is the same as this mass, and therefore they will just show you one peak there. At 33, they will overlap at the same point. 17, 17 and 16, 18 are two different molecules as a result of two different isotopes combining together, but they have the same mass combination. When you did the math using your calculator, 34 and 34 will just produce one peak at 34. Similarly, you could then go on to oxygen 18, 18, 16, 18, 17, 18, 18, and you look at the different mass. So altogether, the different masses are 36, 35, 34, 33, 32. That's why you get 5 different peaks that will be associated with these molecules that contain 2 oxygen atoms. Now, this next one, number 4, is much, much trickier because now you have got 3 chlorine atoms. In your work 4, I think it was just 2 chlorine atoms, and some people were already confused. This is even worse. This has got 3 chlorine atoms. But what is important is chlorine only has 2 isotopes, 35 and 37. The C2H3 is fixed. So that means we're just considering the different combinations of the 3 chlorines. Okay, I'm going to ask a couple of questions now. Hopefully people can just unmute themselves and answer me as part of lesson, right? Okay, Hazik, are you there? Hello, Hazik, are you there? Hello, Hazik, are you there? And Hazik is not there. Bazila, are you there? Hello, Bazila, are you there? Can you hear me? Bazila is not there. Okay, Isa, are you there? Hello, hi Isa, are you there? And Isa is not there. Kashfi, are you there? Are you there, Kashfi?
Yes, sir.
Oh, hi, Kashfi. I'm glad you're there because the other three people are not there. Okay, you got three chlorine atoms. So how are you going to combine their masses? Remember that you only have two different possible isotopes, only chlorine 35 and 37. How are you going to combine the masses here? What is going to be your first combination? This is mathematics, right? Come on, tell me, what are your combinations? What is possible? Possibility. You understand the question, Kashvi? Like just now, you have two oxygen atoms because you only have O2. So that means it will be two things sum up together. Here, you have three chlorine atoms. The first chlorine atom could be chlorine 35, could be chlorine 37. You see, it could be chlorine 35 or it could be chlorine 37. The second one could be chlorine 35 or chlorine 37. The third one could be chlorine 35 or chlorine 37. So your goal really is to determine what are the different combinations. So give me the first combination. What would you get? What do you think? There's more than one, trust me, there's more than one. Just choose the easiest one. Just choose the lowest mass. What are the lowest mass?
35.
35. How about the second one? The lowest mass will be?
35.
And then the third one, what will be the lowest mass for the third one?
35.
So guess what? Your three combination now is going to give you 35 plus 35 plus 35. That will give you the lowest mass. These are combination number one. Okay, let's try combination number two. Hazik, are you there?
Yes.
What is going to be the second combination you can think of? So try to change one thing at one time. Don't change all three at one time. Try to be systematic. I'm teaching you the math behind it. This is mathematics. Yeah, this is not chemistry. Okay, come on, just change one thing at one time. So it's up to you which one you want to change, but change one thing at one time. So look at the first one and look at the second one. What would you get? So you have three chlorine atom, right? So you have two possibility for each chlorine. Two possibility for each chlorine. Okay, come on, tell me your combination.
35.
Go on, what else? Don't wait for me.
35. And 37.
Okay, that is great. There's a second combination. I hope everyone is seeing the idea. You are doing combination, okay? Just the possibility, okay? Isa, are you there? I don't think Isa is there. Carrie, are you there?
Yes.
What is the next combination that you can think of? Remember, change one thing at one time. Change one thing at one time. What is the other combination you can think of? So Hazik has done, these two remain the same. So it only change the last one. So it seems like I cannot change the last one anymore, right? Okay. So what else can I do? What do you think, Kairia? What would you get? Fill in the three columns. And this is a 1 minute question, yeah? 1 minute to get everything. So you need to learn to think faster. Come on, Kairia. What do you get?
35.
Don't wait for me. What else?
35.
What else?
39.
39. But I only have two isotopes, chlorine 35 and chlorine 37. It's called reading question. I only have two isotopes. I don't have 39. I do not have 39 according to the question. So you're wrong. I cannot have 39. What can I have? Well, let's ask Mikhail. Are you there, Mikhail? Mikhail is not there. Let's ask Basira. Basira, are you there? Haven't seen you for some time. What is going to be your combination, Basira? Basira is not there. Kawim, are you there?
Yes, sir.
Hi, what do you think is the next combination? So Carrier couldn't get this. What could you get? So there's no isotope 39, yeah? The question said 35 or 37, only two isotopes. So what is your next possible combination?
35,
Uh-huh.
37,
Uh-huh.
and 37.
Okay, you could actually do 35. You could actually get this as well. So I'm going to do this 35, 37, 35. But then you will see that 35 and 35 the same. This 35 plus 37 is the same as 37 plus 35. So can you see that they are the same? They will give you the same mass. So that's why I don't double count that. I think that was the reason why Kawim didn't mention this, because this will give the same mass. But as you are doing this kind of combination, you write every single possibility first, and only then you decide apa yang sama, whichever one is the same, then you don't count them. Okay, so I don't count this because 35 plus 37 plus 35 is the same as 35 plus 35 plus 37. Even without clicking my calculator, I should be able to see this. 35 plus 37 is the same as 37 plus 35. Okay, so I don't count that. I don't count that. Okay, what is my next combination? Let's ask Azam, are you there? So I think Kawim already finished off the same thing, like 35 for the first one. So you can kickstart the next one. What is going to be the next one? Any idea? Okay, Azam is not there as well. Is Sahiro around? Sahiro is not around. Not surprised. Oh, Sahiro is around. Hi, Sahiro, are you there? Hello, Sahiro. We're waiting for you. Hello, hi, Sahiro. Okay, he's not there at all. Okay. Anyway, so let me just go through the other combinations. The other combinations, so I already turned all these 35, already constant. So now I'm going to make the middle one the same. So I'm just going to make the middle one 35. 35, I don't change the middle one. I change the, okay, maybe I should be systematic. Maybe I should go 37. Now, if that is 37, so that would be 35 and 35, possible, okay? And then I could get, what else can I get actually? I could get 37, 35, 37. I could get 37, 37, 35. And what else can I get? I could get 37, 37, 37. All right, happy so far? Now I'm gonna ask Raymond. Are you there, Raymond?
Yes.
Raymond, is this different from what I have gotten before? Is this a new peak or is this not a new peak? Remember
No.
what you see is not a new peak because this is the same as 235 and 137. 235 and 137. So I don't count this. Okay. Is this next one a new peak or not new peak, Raymond? So it's a different combination, right? But is this a new peak or not, Raymond?
No.
So 2 of 37 and 1 of 35. 2 of 37, 1 of 35 already counted before. So this is not a new peak. How about the next one? What do you think, Raymond?
Also not.
Not, because 2 of 37 and 1 of 35, they will overlap to give you the same mass. So that is also not. How about the next one, Raymond?
Yes.
This is a new peak because 37, 37, 37 will give me a different value from what I have gotten before. So altogether, I hope you can see how many different molecular masses are possible. Yeah. Did I miss out anything? Do you think I missed out anything at all? So 35, 35, 35, this is the lowest. I can assure you that is the lowest value because it's the sum of low, low, low. Now 37, 37, 37 is the highest because it's the highest value plus the highest value plus the highest value. Anything in between, this is 130. Hang on, what have I done? This is 135 to 37. This is 137 to 35. So these are the other two possible combinations in between. So altogether, I have 4 different combinations. Are you guys okay? Does anyone have any question on this? Because if you got any questions on this, if you don't know how to do this, you will have problem with simple O-level mathematics. This is about combination. Yeah, I haven't picked up my calculator at all. In fact, I don't need my calculator at all. I just need to know. I just need to see the numbers. I have 2 different isotopes according to the questions. Okay, and question will change. They will give you different isotopes. You cannot expect the question to be exactly the same in O-level. O-level is not PCE or PSR or SPE. The question will never be repeated, but the concept will be repeated. Okay, so I hope that makes sense there. Now I'm going to skip this calculation bit in the syllabus first. I'm going to go straight to the very last section of this topic. Since you already done isotopes, this is page number 13 in your notes, page number 13. This is the very last bit in the syllabus. So it says, state that isotopes of the same element, same chemical property. This is the property of isotope. So just because you are isotope does not mean you have different chemical properties. This word chemical property, this is a topic called atomic structure, and this is a subject called chemistry. This is carbon and carbon. This is pronounced as carbon 12, carbon 14. That was what we did in the last lesson. Okay, so in terms of protons, electrons, and also neutrons, those are the kind of thing we always do. Protons, electrons, and neutrons. When you did your MCQ, the first mistake you did was you did not even show this kind of simple calculations, and that was why many of you didn't score well at all. And you will continue to fail in this subject if you don't annotate or write something on the question as you read along. The proton number is the number at the bottom, but it's not given because you have your periodic table. Your periodic table shows you the proton number or the atomic number. The number at the bottom is smaller. The smaller number on the left, smaller than the number on the top left, because this is the international nuclide notation. It was suggested to you already that we corrected your work 2 before your SSRE, work 2, okay? So that number at the bottom is your protons or atomic number. The number on top there is your mass, or what you call nucleons, the total number of protons and also neutrons in the nucleus of an atom, as stated in the Cambridge syllabus. Candidate should be able to define nucleon number as something, something, something. Candidate should be able to define proton number as something, something, something. These are isotopes. Isotopes are atoms of the same element. So that means since they are atoms, therefore, the number of electrons must be equal to number of protons. And since the number of protons is the same, the number of electrons is the same. Number of neutrons, nucleons number, the higher number on top minus the smaller number at the bottom. This is not periodic table. Periodic table is what is given. This is what is given in question, not the periodic table. Be very careful. It's not the first time I have warned you, but it wouldn't be long until you are on your own when you sit for your topical test sometime next week, okay? So they have the same number of electrons, and therefore they have the same electronic configuration. Electronic configuration is also known as electronic arrangement. As you are, viewing these lectures, you have your notes next to you. If you don't start writing down some stuff, we will not come back to this, okay? You also have your textbook that, you can read on your own and annotate your notes. Your notes are your notes. It's not my notes, okay? It is your note, okay? My job is simply to break down the concept for you. So in terms of the electronic arrangement, we look at the number of electrons. If you have 6 electrons and 6 electrons, because you can get from the number of protons and the fact that these are atoms, so that means electronic arrangement will be 2 in the first shell and 4 in the second shell, because the first shell, the first row of the periodic table, the first shell can only fit 2 electrons, and then you are fully filled, you have 6. So you have 4 more that you need to fill in the second shell. But then you realize the number of electrons in this isotope, carbon-14, is also 6. So that means they have the exact same electronic configuration. That's because their total number of electrons is the same. Therefore, they have the same electronic configuration. That means they will have the same chemical property. As simple as that. When a question asks you in structured paper, they will ask you, can you explain about the chemical reactivity of these 2 isotopes? Well, they will be the same. Explain why. Because of this. So state the total number of electrons, state it as you know how to calculate, and therefore they must have the same electronic configuration. Chemistry is to do with the electrons, especially the electrons in the outer shell. If you have the exact same number of electrons in the outer shell, you're going to have similar chemical reactivity. Okay, so hopefully that makes sense to you. You can read through this on your own. Physical properties. So remember this thing, the states of matter. I have a feeling that I won't be able to come to school on Wednesday, which means on Wednesday will be your topical test for states of matter. Okay, I repeat again, yeah. I might not be able to come to school on Wednesday. So Wednesday is your states of matter topical test, which will include all this idea of diffusion and stuff. Okay, you learned these already in topic 1, NH3 versus HCl. You know how to calculate the MR of HCl. That was 1 plus 35.5 because there is one atom of these and there is one atom of chlorine. This is the sum of the relative atomic masses in your periodic table. They give you something which they label relative atomic mass. They never ever say that that is mass number. They don't say it's mass number. They don't say it's nuclear number. They say it's relative atomic mass. So do not say that this is mass number. Do not say this is nuclear number because that is not true. There is relative atomic mass. At the top, however, they say there is atomic number in the periodic table. Of course, there is atomic number because there is the number of protons. Okay. So in topic 1, you know how to explain this already because you know how to calculate relative atomic masses and sum them up. You know, this is lighter. Lighter means it has lesser mass than that, lower MR, so it will diffuse faster. So it's lighter, so it diffuses faster. Okay, so the heavier you are, heavier particles, heavier molecules, they will diffuse slower, which is why this meeting point is slightly closer to the concentrated hydrochloric acid because this will diffuse slightly more towards that side, faster than the hydrochloric acid can diffuse from that side. Diffusion is your case study. They got 3 points to diffusion. The essay or the definition for diffusion, remember the first point is to do with the random movement of particles from a region of high concentration to a region of low concentration until concentration become uniform. I can say that all there, but it was something that we did. It was something that we did corrections on. It was something that you will have revised as you go through topic 1 on your own. Now, why do we talk about diffusion and why do we talk about it in the context of isotope? We learned about chlorine. This is a specific case study, okay? I think Peria got this one wrong just now because she didn't appreciate the question. The question said chlorine 35, chlorine 37. Chlorine only has 2 isotopes, chlorine 35, chlorine 37. So now, when you have the HCl, this is what we do in topic 1. But in this topic, you have isotope. So you know about the hydrogens and then chlorine 35. The MR is going to be the sum of the mass number, the mass or the nucleon number, the number of nucleons, 35, and then plus 1, that gives you 36. The isotopes mean they have different number of neutrons. So when you have different number of neutrons for the chlorine 37, your MR is 1 plus 37. This gives you 38. Because these things have different masses, they will travel or they will diffuse at different rates because they have different mass. So this is heavier, this will diffuse slightly slower. This is lighter, this will diffuse slightly faster. In the context of topic 1, we never really care about chlorine 35, chlorine 37, unless the question specify on this. Unless the question specify, we just look straight from the periodic table. Okay, this is what we always do. But unless the question specify, we always just go straight to periodic table. Now we'll go through a couple of these questions. It's not the first time I've gone through multiple choice question with you, and it will not be the last time, but you will really fail really badly if you do not start annotating your question, okay? This number 14 on top and number 12 on top. Okay, I'm gonna ask some question now. Not Mikhail, let me ask. Isa, are you there, Isa? Hello, Isa. Isa is online, but she is not there. Hello, Isa. Nope, Isa is not there. Basila, are you there? Hello, Basila. Nope, Basila is not there. Okay. Sahiro has left. Okay. Adri, are you there?
Hello.
Hello, Adri. What is this number
Hello.
on top? What is this number on top? What does it tell you? Yes, Adri. What does this number on top tell you? Very simple question, right? That was what I just went through for half an hour. What is
Mass
this number?
number. Mass number.
Okay. What is the other name for mass number?
nuclear.
Nuclear number. And what is this number at the bottom, Audrey?
Protons.
Okay, I hope you weren't referring to your notes, yeah? Because, when you sit for the test in
Yes.
school, you won't have your notes next to you, okay? Which statement about this isotope is correct? Correct, okay? Now, we look at A, B, C, and D. We read, and we need to be very careful as we read, okay? It says more reactive. But what do we know about isotope? Same chemical reactivity. That is today's lesson, same chemical reactivity. So it behaves the same way, same chemical reactivity. So more reactive is definitely wrong. So the reactions are similar, that is correct. That means same chemical reactivity. And the reason why they have same chemical reactivity, as stated in the syllabus just now, is not to do with the same number of protons, even though this is definition of isotope, but this is not the reason. This is not the reason for why they have the same chemical property. In the syllabus just now, it says because they have same number of same number of electrons, therefore same electronic configuration. That was as stated in the syllabus. Cambridge really want you to be able to write this particular reason. Same number of electrons, therefore same electronic configuration, therefore same chemical reactivity. Hopefully that makes sense there. Now next one, I hope everyone has a periodic table next to you. So they haven't given you the proton number or the atomic number. Someone's going to tell me. So they want the neutrons, right? So I don't care about protons, I just need the neutrons. So what is going to be the proton number of borons? Karia, are you there? Karia, proton number of boron? Hello, Karia, proton number of boron? Nope, maybe Azam can help. What is the proton number of boron? I can't hear you, Azam. Oh, Carrie, I can't hear any of you at all. Are you talking at all? Okay. Okay, I can hear you now, Carrie. What is the proton number of boron? I can't hear you at all. You are mumbling. You have a periodic table next to you. You already drew for the first 20 elements. It's quite unfortunate and it's quite a shame if you can't even identify the first 20 elements. Nope. I think she is going to get her periodic table. I hope everyone can get 5 and 6. So 11 minus 5 is 6. 12 minus 6 is 6. You can't really do chemistry without a periodic table, yeah? So don't know. Don't really know what is wrong, okay? So the rest of it, you can try on your own. But in the MCQ, I already got my answer. I go from A, B, C, D. Once I got my answer, I move on. But I make sure that I get the correct answer, okay? Now this next one is quite tricky because of the unusual abbreviation here. So what is this number on top again, Karia? This number on top, what does it tell you?
Proton.
Oh, goodness me. Nope. You were not listening when Adri said just now. You are still looking at periodic table. Periodic table is not international standard. This is to the far left. No one can help, yeah? No one can help if you don't help yourself. It's nuclear number. It was why you get 0 out of 12 for the whole MCQ. The rest of you need to do your own correction as well, yeah? Okay, and this is only atomic structure, the second easiest topic in the whole of O-level. The number at the bottom is proton number, atomic number. No need to look at the periodic table for this because this is given in the question. Once you know this, then you know how to get it. Unfortunately, if you are like Karia and she thought the top thing is proton number, she is gone because she will get the wrong answer for this. Okay, Isa, I hope Isa is there because she was never there from the very beginning. Is Isa there? Not really. Mikhail, are you there? Hello, Mikhail. And Mikhail is not there as well. Okay, never mind. The rest of you should know what to do. Nuclear number of 105 is wrong. That is proton number. The proton number is 105. The nuclear number is 262. Okay, A is wrong. You want correct. The atom is an isotope. Definition of isotope, you are playing this in your head, atoms of the same element. So 105 and 105, you see, same element because same number of protons. Same number of protons, the number of proton is at the bottom left. The number on the top, you could see 262 and 260, different number of neutrons. So 262 minus 105 is different from 260 minus 105. I don't need my calculator for this because the proton number is the same. If the number of neutron is different, the mass number or the nucleon number will be different. B must be correct there, okay, because of the definition of isotope. The next one, 262 neutrons is wrong because 262 is actually what you call nucleons. Definition of nucleons, both the protons and the neutrons in the nucleus of an atom. The very last thing, the proton number is at the bottom, so it's not 262, it's 105. So C and D are wrong as well. Question number 4 is the very last thing I'll do. So what happened there is, what is the same number of electrons? This question is very, very tricky because of molecules. So far, you've only done counting the number of electrons in atoms. You haven't done for molecule. So how in the world do you do for molecule? It's easy. I will show you for one, and then you will tell me. Now, we know the number of electrons equal to number of protons if no charge. Your atom is no charge. So atom has no charge. Atom is uncharged overall. So far, you know that. Now, this is a molecule. A molecule consists of 2 or more atoms combined together. Elements, compounds, mixtures, molecules, those kind of stuff. Molecule is also uncharged. You look at the molecule there, none of them have any charge. So if molecule is uncharged, that means the number of electrons equal to number of protons. So be very careful. You are not calculating MR, not calculating MR. I want to focus on this, yeah? You are not calculating masses. You are calculating number of electrons. So we look at proton first. Look at proton first, okay? Look at the number of protons. How many proton does one chlorine have? Kawin, how many proton does one chlorine atom have? One chlorine, how many proton?
2.
That is wrong. Proton. Can you find chlorine in your periodic table?
35.5.
Nope, that is also wrong. I just said not calculating MR. Not calculating MR. What are you kidding? Chlorine 17 and 35.5. 35.5 is relative atomic mass. This is atomic, or what you call proton number. So how many protons are there in one chlorine? If you have one chlorine, how many protons are here? Yes, who did I ask just now? Kawim already disconnected. Yes, Kawim, you still there? How many protons does one chlorine atom have?
17.
17. So how many chlorine atom? Sorry, how many chlorine atom are there here? There are 2. So how many proton does Cl2 have? So you have one atom, there's 17. So if you have 2 atoms, how many protons are there? How do you work it out?
Times
What do you
2.
need to times 2? All 17 plus 17. So that gave you 34. Okay. Now, if you have atom, you know the number of protons equal to the number of electrons because they are uncharged. Now you have a Cl2 molecule. You have 34 protons. Like I said, you are not doing mass. I said it again, yeah? You are not calculating MR. You're calculating the number of electrons. So you look at the protons. Protons is atomic or proton number definition. If you have 34 protons, how many electrons must you have, Kawim, if you want the molecule to have no charge? How many electrons must you have in the Cl2 molecule? You don't get it? You don't get it? 17 protons
No.
must cancel 17 electrons. Atom has no charge. Molecule has no charge. There is no charge. There's no
34.
plus. Of course, it must be
34.
34 as well. So there's 34 electrons here.
Yes.
Now let's have a look at SO2. Okay, how many proton does SO2 have? Okay, thank you, Kawim. I'm gonna ask Azam now. Azam, are you there? How many proton does SO2 have? How do you work it out, Azam? Azam is not there anymore. Hazik. Hello, Hazik.
Yes.
What is the number of protons here? So you have one sulfur. What is the number of proton in one sulfur?
16.
Okay. How many protons do you have in one oxygen? If you have one oxygen, how 8, but you have 2 oxygen. So you have 8 times 2 or 8 plus 8. So 16 plus 8 plus 8 will give you 32 protons. So how many electrons does SO2 molecule have? So it's a molecule which is uncharged. So the number of electrons must be equal to the number of protons for the whole molecule to be uncharged, right? So how many electrons must SO2 have?
32.
Also 32 electrons. And guess what? They want the same number of electrons, so A cannot be the answer. Okay, I'm going to go for B, CH4 now versus H2O. Now, Hazik, stay with me. How many protons does carbon have?
6.
How many protons does hydrogen have?
1.
And you have 4 of them. So how many protons do you have altogether in CH4?
10.
So you have 10 protons. So therefore, you have 10 electrons. Now tell me, how many protons do you have in H2O molecule? H2O molecule, the whole thing, what would you do? You can tell me you're working, because working is more important. What would you do?
1 times 2
Yep, because you have 2 protons from the 2 hydrogen, and then
plus 8.
plus 8. Be very careful, yeah. I want to focus again, yeah. Some people keep on thinking about MR, but they forgot that it's the number of protons. They come from the proton number. So 10 proton mean 10 electrons because the molecule is uncharged. 10 electron in CH4, 10 electron in H2O. These are the same number of electrons there. Okay, so that's it really for this bit of the syllabus. I mean, that was just about chemical reactivity. You should really brush through all of these. These are in Isotopes 3 in the lecture series, okay? I will have to leave this one for the... Actually, I'll very quickly go through this, but I'll cover more in the next lesson. I see you, yeah? The rest of the people, they just have to catch up on their own, okay? We're actually quite far behind for this class, yeah? And on Wednesday, if I'm not around, that means you guys will be sitting for the states of matter topical test. Now, what is going on with this thing here? This thing here is about relative atomic mass. This is definition. They will ask you what is meant by relative atomic mass. Make sure that you are not just copying the definition. Make sure you know what it means. It's to do with the average mass, but some people just stop at average mass. They forgot that it has to be compared to or relative to 1/12. This is 1/12 of the mass of an atom of carbon-12. This is a fixed definition. You cannot lose mark on a fixed definition. What they are saying is elements can have different isotopes. And how do we know that they have different isotopes? Because when we pass the atom through this machine called mass spectrometer, as you have seen in the early bit of these lessons, that you have a mass of a charge. So if you have different mass number, you will have different peaks. So if you are element, if you see 3 peaks, that means 3 isotopes. If you see 4 peaks, it means 4 isotopes. If you see 2 peaks, it means 2 isotopes. And what do? What you get in the periodic table is what you call relative atomic mass. It's simply an average value. It's an average value. You think back on chlorine. This is the most common example. Chlorine 35 and chlorine 37. These are the 2 isotopes. Okay, these are the 2 isotopes. This is the very last thing I'll do with you. Yeah, and then the rest of it you can read out on your own. Okay, chlorine has 2 isotopes, chlorine 35 and chlorine 37. If you see the periodic table according to Kyria just now, 17 on top, 35.5 at the bottom. This is not mass number. This is not nucleon number. Why? How can you have half a nucleon? You cannot have half a particle. It doesn't make sense. It's ridiculous. It's impossible. It just doesn't make sense if you are thinking like that, okay? This number on top is called the atomic or proton number. That is because the actual number of protons is the same for isotope. Electrons is the same because they are atoms of the same element, same number of protons, so same number of electrons. Neutron is different. As you can see that there is 18, 37 minus 17 is 20, different number of neutrons. These are whole number. We are talking about number of particle. This must be whole number. This is 35.5. When you do 35.5 minus 17, you get 18.5 nucleons. This is wrong, impossible. That is because this is relative atomic mass. The definition, Cambridge said, candidate should be able to define it. If you cannot define it, I'm sorry, Cambridge already told you so. I already told you so. You just didn't want to listen, okay? It's to do with average mass. When you do averaging, this is what you do in primary school. When you have 1, 1, 2, what you do is 1 plus 1 plus 2, and then you would divide by 3 because there are 3 numbers. Total sum of the readings divided by how many readings you have. That is what you would do in primary school. But if you press your calculator, you will see this on the screen. 1 plus 1 plus 2 divided by 3. If you press like this on the calculator, you have made a mistake. If you don't believe me, you can press your calculator. 1 plus 1 plus 2 divided by 3, and then you will get an answer. You will get an answer which is ridiculous. You get 2.667. What you have done wrong really is you haven't seen the number. This is the lowest. This is the highest. What does average mean? Average means it must come somewhere in between the lowest and the highest. How can your average be higher than highest value? How can your average be lower than your lowest value? Average must come in between. That is because you have done something terribly wrong in mathematics. In math, you have learned bracket first, then division, multiplication, addition, and subtraction. You do bracket first. Then you do divide or multiply before addition. Your calculator will recognize this as to do first, but this is actually wrong. What you want is you want a bracket. Make sure you know how to use a bracket in your calculator. Now, if you do 4 divided by 3, you get 1.33. So that means your average is actually 1.33, is between the lowest and the highest. Average cannot be higher than the highest. Average cannot be lower than the lowest. This is the most basic mathematics you can ever learn in the whole world, all right? Now, the use of bracket, very important. Make sure you can do that, yeah? Now, this thing here, we just divide by 3, but this thing here, they have the same percentage abundance. When you are talking about mass numbers, you're talking about isotopes. Not every single isotopes have the same abundance. You don't just add 35 plus 37, bracket, and then divide by 2. If you do that, 35 plus 37, bracket, divided by 2, you get 36. That is average. But how come this shows 35.5? That is because this is not 1-to-1 or 50% is to 50%. What do I mean by 50% is to 50%? Well, this is where you need to know the case study. This is an important number to remember. Chlorine 35 to chlorine 37, there is 75% of it compared to 25% of it, of chlorine 37. You have more of chlorine 35 than chlorine 37. If you have more of these than this is the lighter mass. So that means your average is going to be closer to 35 because 35 is your smallest number, 37 is your biggest number. Exactly in between is 36, but your average is not 36, your average is 35.5 because you have more of the chlorine 35. Your actual value, relative atomic mass, AR, is 35.5. From your predictable definition of relative atomic mass, average mass of the atoms of the isotopes relative to 1/12 the mass of an atom of carbon-12. Not too sure if I'm just speaking on the screen or if people are actually listening from the other side, but these are the important things that you would need, as well as things you can read from the new textbook chapter, which I share with you. How in the world do they get 35.5? To do AR calculation, to calculate relative atomic mass, look at the percentage. The percentage is 75% multiplied by the mass number. The percentage multiplied by the mass number. Then you add them up together. This is plus. I could do 37 times 25, not a problem, as long as it's mass number multiplied by the percentage of that mass number. 35 times 75 is the same as 75 times 35. This number, addition on top, add them up together. I divide by what? I want the mass, so I don't divide by the mass. I divide by the sum of the percentage. 75% plus 25%, the maximum for a percentage is 100%, just like your exam marks is marked out of 100%. If you press your calculator now, you should have a calculator when you do this topic. Yeah? If you don't, then get one. And you can get 3550 because I use a bracket. I am very careful with the use of bracket because that is simple mathematics. Then press the calculator, divided by 100, I get 35.5. This is what is shown in your periodic table. This is what is shown in your periodic table. Chlorine 35 is a lot more abundant. There is a lot more of chlorine 35 than chlorine 37. 75% is to 25%. This one, you can simplify it further. This is percentage abundance, but I can get the relative abundance. So basically a ratio, no longer percentage. How can I simplify this further? Any idea on the mathematics involved? Okay, we are nearly the end now, don't worry, okay? Raymond, what can you tell me about the mathematics? How can you simplify this further? You there, Raymond?
Yes.
How can you simplify this further? What would you do?
Divide.
You divide by what?
5.
If you divide by 5, so I will get 25. 25 is to 5. Can I simplify that further? Can I simplify this?
Yes.
Oh, sorry. I don't get 25. I get 15, yes. Sorry. So what can I do further? How can I simplify?
5.
Divide by 5 again. So I will get 3 is to 1. So altogether, I divide by 25. Altogether, I can divide by 25. So I divide by 25 and I get 3 is to 1. This is a very important number. 3 is to 1 is how much more you have chlorine 35 than chlorine 37. It means that when I have a pizza, a circle like this, if I cut it into 4, because altogether I have 4 fractions. So what happened is 3 out of 4 is chlorine 35, whereas the 1 out of 4 is chlorine 37. You have a lot more of the chlorine 35. That's why your average is closer to 35 and not closer to 37. And your average is not exactly in between because you have a lot more of the chlorine 35. That was why you multiply the percentage by the mass number, the percentage by the mass number, and then you sum them up before you divide by the sum of the percentage. Now, Raymond has done this simplified ratio. This is percentage. This is percentage abundance. Percentage is out of 100%, but then ratio is not out of 100%. This is ratio. Ratio doesn't have the percentage to it, but this is also chlorine 35 is to chlorine 37. The very last thing I'll show you is you can use ratio also to work out relative atomic mass. We're going to do the exact same thing. 3 times as much of chlorine 35 as chlorine 37. So chlorine 35, the mass number 35, multiplied by this abundance, 3, or 3 times 35, I add them up, sum them up, plus them. This is 37, mass number times the 1, or 1 times 37, and then do a big bracket so that you don't make a mistake. I do not divide by 100% because I don't have percentage here. Instead, I divide by 3 plus 1. So I divide that by 3 plus 1 there. My relative atomic mass, press my calculator, I get 4 at the bottom. On the top, 35 times 3 plus 37 times 1, I get 142. Now 142 divided by 4 on my calculator, I get 35.5. I get the exact same value, whether I use the 3:1, but I divide by 4, or I do the 75% to 25%, where I divide by 100%, I will get 35.5. This is relative atomic mass. It is what is defined in the syllabus as the average mass. It is not an exact mass. You do not have 0.5 nucleon. Instead, what you have is actually chlorine 35, chlorine 37, but you average the mass for all the isotopes relative to 1/12 of the mass of an atom of carbon-12. That is the full definition of AR. What I will leave you to do is, you can do this question on your own. This is the percentage, this is the mass number. Multiply them together, multiply them together, multiply them together, add them up. So AR will be 24 multiplied by 78.60. I do bracket multiply like that, and then 25 multiplied by 10.11, and then 26, 11.29. Do another big bracket. Percentage is out of 100%. Percentage is total out of 100%. You can check on your calculator. Whatever you do, do not do everything in one go, but write down your working, complete the working, and then show it there. Okay, show it there. So not need to show the error, but you got to put in the value there, and then give a value for significant figure. We'll continue this in the next lesson that I actually see you face to face. But you can also try this question, where this one is relative abundance, and this is no longer percentage. What is more important is things like this. You have to be able to work backwards. This is called mathematics. So when you work backwards, the total percentage is out of 100%. You have the percentage for 1, 2, 3, but there is a fourth one. You don't know the mass. You don't know the mass. You don't know the percentage, but you have the percentage for 3 of them. So you can work out the percentage of the fourth one. 100% is the total minus the difference. You sum up the other 3, then you total up and take them away from 100%. You will get the percentage of the other one. And I just want to show you the mathematics. I did tell you last time that you need to be quite good with mathematics. Otherwise, you will suffer, not just in physics, but also in chemistry. They give you the answer here because the AR, which is 87.71, is equal to something divided by 100%, because I am given percentage here. I have 86 multiplied by 9.86 plus 87 multiplied by 7.00. Mass number multiplied by percentage. Add them up together. The next one is 88 multiplied by 82.58. But the very last one is tricky. The very last one is tricky because I have the 0.56%, but I don't have the mass number. Mass number is a whole number. So make sure later on you give a whole number. Okay, so this one will be 0.56 x. Your job is find x. These are numbers. Numbers you can do on calculator. X you cannot do on calculator. This is divide by 100. Bring up the 100 to the other side, or in mathematics, in primary school mathematics, you will say multiply by 100 on both sides. You will get 87.71. Multiply by 100, you get 8771. This value, if I press my calculator, I will get 8724 for all of this value. This is not a value. I cannot do x on my calculator. This is plus x, so 0.56x. This one, I move it to the other side, and then I will get negative, so become minus. So 0.56x equal to 8771 minus that value is 47. So x is equal to 47 divided by 0.56. I get 83.9. Remember what I said? Mass number is basically your nucleon number. It has to be a whole number. Okay, it's not your average mass, it's your whole number, total number of protons plus the total number of neutrons. What you get then is 83.9. So you have to round it up to 84. How do I know my answer is roughly correct? Well, you can put it into the expression again. You should get 87.71, or they are pretty close to this value. They are pretty close to this value. Very little of 84. A lot of it is 88. That's why the average come very close to 88, because you have a lot of the mass concentrated at isotope 88. I think that's all the time I have for today. So there's a 1 hour class. People who miss it, well, people who miss it, they just miss it, okay? There's nothing I can do about the backup class anymore, okay? But next week, if I'm not around, on Wednesday or Thursday, whenever you're next in school with me, you will have the topical test on stats of matter. Okay, thank you, everyone. Make sure you fill in your notes. These are in Isotopes 2 and Isotopes 3 lecture tutorial in the playlist in the group chat. Okay, have a look at the atomic structure playlist, Isotope 2, Isotope 3. Make sure you can do the math on your own. Thank you. Have a good day.